2.5 Writing quadratic functions in vertex form. Today we are going to write quadratics in vertex form from standard form. When we look at a perfect square trinomial, if we have a squared plus 2ab plus b squared, it would equal a plus b squared. If we have a squared minus 2 times ab plus b squared, it would result in the binomial a minus b squared. So when we create a perfect square trinomial, we look at our terms. Remember, in front of our x squared is our a, in front of our x is our b. So if we do 2b and we set that equal to 8, divide by 2 because it's the inverse, we get b is equal to 4. So b divided by 2. Then we put x minus 4 squared as our binomial squared, and when we distribute that out, we would get back to our perfect square trinomial. Sometimes you need to add a term to an expression, x squared plus bx, to make it a perfect square trinomial. This process is called completing the square. To complete the square for the expression x squared plus bx, we would add b divided by 2 squared. So if we have x squared plus bx plus b divided by 2 squared, and we factored that perfect square trinomial, we would get the binomial of x plus b over 2 squared. So when we complete the square for each of the expressions, we would like to write the results as a binomial squared. So if we were using tiles and we said we were trying to complete the square and we had x squared as this large red tile in the corner, and if we put 7 x tiles these green ones are x tiles, and we have 7 on this side. These are all x tiles, so that 7 and 7 equals our 14. How many unit tiles would we need to complete the square? So we are looking for all these unit tiles in this bottom right hand corner. So if we divide 14 by 2, we get positive 7. So b divided by 2 equals 7, which goes in this blank right here. And then b divided by 2 squared, so 7 squared equals 49. So we need 49 unit tiles in order to create this perfect square trinomial with the dimensions x plus 7x, or 7, because we have 7 1-unit spaces right here, and x plus 7. So looking at the next example, you could draw your square if you needed to, and put your x squared in the corner, 6 x's on either side. So if you have 6 1s and 6 1s to complete your square, you should have 36 unit tiles. So now let's do the algebra behind it. Negative 12 divided by 2 gives us a negative 6 in our binomial, and negative 6 squared gives us 36, which created our perfect square trinomial. So if you prefer to draw the picture, it will work every time. So this slide just goes over the different forms that we have for a quadratic equation. We're going to start in standard form. We're going to find the axis of symmetry by doing negative b over 2a. We then are going to rewrite that in vertex form by completing the square. And notice when it's in vertex form, HK is going to be your vertex, and notice that your H, whatever's inside your parentheses, is always opposite. We can complete the square to rewrite any quadratic in vertex form. The steps for completing the square is followed. We are going to move the constant to the right side of the equals. We are going to factor out the leading coefficient because you can only complete the square if the coefficient of x squared is 1. We're going to take 1/2 the coefficient of the x term, square it, and add it to both sides. We're going to simplify the right side of the equation. We're going to factor the left side as a perfect square trinomial, and we are going to solve for y. So the first thing we are going to do is we are going to move our constant to the opposite side of the equation by adding 12. So we're going to have f of x plus 12 is equal to x squared plus 16x plus box. If we add a box to the left-hand side of the equation, we must add, the right-hand side, we must add a box to the left-hand side as well. We're then going to complete the square, which is going to give us some binomial squared. So to figure out what goes in this space, we are going to do b divided by 2. So 16 divided by 2 is going to give us 8, positive 8. We then are going to square that, b divided by 2 squared, which gives us 64. So 64 goes in our box, and whatever we add to one side of the equation, we must add to the other. We then want to combine our like terms. So 64 plus 12 gives us 72. So f of x plus 72 is equal to x plus 8 squared. Then, 76. And when we move our 76 by subtracting it, we get f of x is equal to x plus 8 squared minus 76. We then know our vertex in vertex form is the opposite of positive 8, so our x coordinate is negative 8 and our y is negative 76. Example B, we're going to first start by moving our 18. So we have f of x equals, f of x minus 18 plus box equals x squared minus 8x plus box. Set up your factor for your binomial. So off to the side, we're going to do b divided by 2. So negative 8 divided by 2 gives us negative 4. Goes in our binomial. We're going to do b divided by 2 squared. Negative 4 squared gives us a positive 16. Negative 18 plus 16 gives us a negative 2. The inverse of negative 2 is plus 2. So we get f of x is equal to x minus 4 squared plus 2. Our vertex of this quadratic function is at positive 4, positive 2. You can check your answers using the equation for the axis of symmetry. So if you take b divided by 2, negative b over 2a, for the axis of symmetry, negative 8 over 2 gives us 8 divided by 2, which is 4, and you can see that the x coordinate of our vertex is correct. Looking at example C, I noticed that my a, or the coefficient in front of the x squared term, is not 1. So you must factor that out. So when we factor out a 3, before we do that, we want to move our 7 by subtracting it. So we get f of x minus 7 equals 3x squared minus 18x. When I factor out a 3, that's the same as dividing. So we have 3 times the quantity of x squared minus 6x. We're going to add our box for our perfect square trinomial. On the left-hand side, we're also going to add a box, but because we factored out that positive 3, we need to place that on the outside of our box as well. We then are going to go about this problem the same way. Create our binomial. Bring your 3 down in front. B divided by 2 gives us negative 6 over 2, which is negative 3. B divided by 2 squared gives us negative 3 squared, which is 9. 3 times 9 gives us 27. Combined our like terms, so we have a positive 20. The inverse of positive 20 is subtraction. So we have f of x is equal to 3 times the quantity of x minus 3 squared minus 20. In example D, we're going to move our 8 first, add a box. We notice that we need to factor out a 2. So we get 2 times the quantity of x squared minus 3x plus box. Our 2 goes on the outside of our box. When we do our b divided by 2 in this case, we have a negative 3. When we divide that, we leave that as a fraction. So 2 times negative 3 over 2 squared. When we square that to place it in our box, you simply, 3 times 3 is 9, 2 times 2 is 4, so it becomes 9/4. It's kind of messy working with fractions, but when we combine all of our like terms and simplify, we get f of x is equal to 2 times x minus 3 halves squared minus 25 over 2. In example 2, the height y in feet of a baseball t seconds after it is hit can be modeled by this given function. It asks us to find the maximum height of the baseball, which is the vertex. So to find the x-coordinate of the vertex, we do negative b over 2a, and to find the y, we plug it into our equation. So when we look at this, negative b would be negative 96 over 2 times negative 16, which when we simplify that, we get 3. When you plug 3 back in to your quadratic equation and you simplify using your order of operations, you get 147. So the maximum height of the baseball, if you're thinking of your coordinate plane, would be 147 feet. In question B, it asks you how long does it take the baseball to hit the ground. So if we're thinking of a player hitting the ball, when it hits the ground would be our x-intercept. So the easiest thing to use is the quadratic formula with a problem this messy. I would not want to use completing the square because my coefficient of my squared term is not 1. So if you plug it into x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, and you simplify, you would get approximately 9.18. So it would take approximately 9.18 seconds for the ball to reach the ground. Don't forget to label both of your answers. In example 3, when you're converting vertex form to standard form, you're simply going to distribute and follow your order of operations. When you distribute,